Right, 9.4b. We are going to be doing still arithmetic sequences, but we're going to focus on summation notation. Kind of fun to say. Summation notation. But like I said, still arithmetic series that we're working with. So you've maybe seen this before in math land. It's the Greek capital letter S for sigma. And this is summation. We're finding a sum with this stuff. So the way that we set this up, I'm going to just write another one here to make some room. This is going to be your n equals, and then it's your starting number. Okay, and then this is going to be your last number, or the end of your setup. End term, that is, not the end value. So then here, we're going to put an explicit formula. Okay. And this maybe looks not like the simplest thing right now, but once you see how we set this up, I think it'll make more sense to you. Here's what we do. So they're going to tell us to evaluate. And let's say it looks like this. So n equals 1 down here. And a 3 up here. And then our explicit formula is 5n plus 1. Okay, so if this is our setup, basically they're saying we're going to evaluate the sum, so add the numbers from the first term to the third term for this formula. Okay, so what that's saying is if I plug a 1 in here, 5 times 1 is 5 plus 1 is 6. Okay, so this is when n equals 1. We want to add to that the sum of everything from 1 to 3, which means we need n to equal 2 and we need n to equal 3. Okay, so if we plug in a 2 for n, 5 times 2, I'm plugging that in right here, okay, 5 times 2 is 10 plus 1 is 11. So when n is 2, then the term is 11. And then for 3, if I plug in a 3, 5 times 3 is 15 plus 1 is 16. So this is saying what is the sum of those three numbers. So 6 plus 11 plus 16, and you may plug that into your calculator, you may do it in your head. Either way, you should be getting 33. Okay, so you're evaluating from n equals 1 to n equals 3. All right, how about this one? Let's say they ask us again to evaluate, and it looks like this. Sorry, that's not the best one. We're going from n equals 4 to n equals 9 for the explicit formula n plus 2. Okay, so what that means is I need to plug in n equals 4, and n equals 5, and n equals 6, and n equals 7, n equals 8, and n equals 9. Okay, I need to plug all those in to this explicit formula. So if I plug in 4, 4 plus 2 is 6, and it's summation, sum, we are adding. If I plug in 5 here, 5 plus 2 is 7, 6 plus 2 is 8, 7 plus 2 is 9, 8 plus 2 is 10, 9 plus 2 is 11. So we're adding all those numbers up, and again, you can just plug that into your calculator, and you get a sum of 51. Okay, so those are pretty straightforward, I would say. They do get a little bit fancier. Here's our third example. Think back to yesterday. Remember yesterday we did the sum was n divided by 2 times our first term plus our last term. We're going to use that in this scenario. So let's say we have this setup. Okay, n equals 1 is here, 50 is up here, and then it's 2n minus 3. Now you could go through and you could plug in all of these numbers. How many numbers do we have here? If we're starting at n equals 1 and going to n equals 50, that's 50 numbers. Do you really want to have to add 50 numbers by hand? Probably not. So what we're going to do is we're going to use this formula and then think about what we need. We need n. Okay, we need n, we need a sub 1, and we need a sub n to plug into that. So if you think about it, n is your number of numbers, right? So we started at 1, we went to 50. 1, 2, 3, 4, 5, that's 50 numbers, right? So n is going to be 50. Then we have a sub 1. So a sub 1 is not 1. It's saying when we plug in 1, what's our first term? Well, if I plug in 1, 2 times 1 minus 3 gets us a negative 1, right? So that's our a sub 1 is negative 1. And then a sub n is our last term, which is the 50th term, right, up here. So if I plug in 50 here, I would go 2 times 50 minus 3, and that would be 97. So a sub n is 97. Well, now we have all three parts that we can plug into our sum formula. So we're going to plug this in. The sum of those 50 numbers is, 50 over 2 times the first term, which is negative 1, plus the last term, which is 97. So it looks like that. If you plug that into your calculator, that sum is 2,400. Okay. Example number 4. So curious what you guys are up to right now. I don't like not having you in front of me. Okay, let's say we have n equals 1. Sorry, this one's kind of kooky. I didn't draw that very nicely. This one's 35, and then our explicit formula is 5 minus n. So again, if we're trying to find the sum, remember this is summation notation, finding the sum, we need to know for our formula, we need to know n, we need to know our first term, a sub 1, and our last term, a sub n. Okay, so ask yourself, how many terms do I have from 1 to 35? There are 35 terms there. Our first term is if we plug a 1 in right here, 5 minus 1 is 4. And then our last term is if we plug a 35 in here, 5 minus 35, or negative 30. Okay, so we have these three numbers that we're going to plug into that sum equation. So it's going to be n divided by 2, so 35 divided by 2, times the first term, which is 4, plus the second term, which is negative 30. And again, you can just plug that in how you see it, or do PEMDAS if you want to simplify one piece at a time. But that comes out to negative 455. Okay, so that's example 4. I would say any questions, but you can't ask me right now. Send me questions if you have them. All right, example 5. For this one, we're going to come up with our own summation notation. And don't forget the explicit formula. This is just a reminder. Remember, we give you all these formulas, by the way. But you're going to use the explicit formula for an arithmetic sequence here. That's this one, a sub n equals a sub 1 plus the common difference times n minus 1, or you could put the common difference back here. That's fine too. So let's say I give you, for example, 5. Let's say I give you this series, 7 plus 11 plus 15 plus ... plus 207. Okay, we need to do 2 things. We need to write this in sigma notation. Summation notation is another way that you can say that. And then we want to evaluate the sum. Okay, so 2 things here. So the first part, we're going to start with our pretty little symbol, which I seem to write differently every single time. So we're going to start always with the n equals 1. That's our first term, right? And then we need to come up with the explicit formula for this. So if you look here, our first term is 7. So remember, it's a sub n equals the first term plus the common difference is what we're looking at here. So this was always plus 4. So we're going to do the common difference times n minus 1. n minus 1 is always n minus 1. So if you simplify this, distribute here, 7 plus 4n minus 4 gives us a sub n equals 3 plus 4n. So this is our explicit formula. 3 plus 4n is going to go here. And then remember, we did this yesterday. This is our a sub n. That's our last term. So we're going to take that and we're going to put it in place of a sub n. So we're going to say 207 equals 3 plus 4n. So take away 3, you get 204 equals 4n, and then divide by 4, and we get n equals 51. Okay, so that number we're going to carry over up here to say there are 51 terms. Okay, so this is part A. This is the write it in sigma notation. We'll call that part A, right? This is sigma notation. Part B is evaluate it. So if we're going to evaluate this, this is what we're going to plug into our sum formula. So it's going to look like this. The sum is our n, 51, over 2 times our first term, right? That's our 7, plus our last term, which was over here, 207, and that would be our setup. So then you just need to plug that in. You get 5,457. Okay. All right, last one. I think you should try this one out. So pause me because I'm not going to stop. But once you see the whole setup, pause me and try it yourself. See if you can come up with it. This is your starting point. You have -5 plus 2 plus 9 plus ... plus 268. Okay, so we want 2 things here. We want sigma notation or summation notation. And part B, we want to evaluate it. Okay, so pause me and try. come back from pausing me. And here's what you should have gotten. So you set it up. We're always going to say n equals 1 here, our first term. And we need to figure out what our explicit formula is. So a sub n equals the first term, right? That's our 5 is going to go here, plus the common difference. Each one of these we are adding 7. We actually did this exact problem yesterday. 7 times n minus 1. So when we simplify that, a sub n equals -5 plus 7n minus 7. So -12 plus 7n. Okay, so that's our explicit formula. Sorry, I got a little messy there. Would be that. But we still need to figure out what goes up here, right? And that number, do you remember where that came from? That would be if we take this number, because that is our a sub n, so we're going to say, let me erase this a little bit. We're going to drop it right in here. A sub n, so 268, equals our explicit formula. So add the 12, you get 280 equals 7n, and divide by 7. So we get n equals 40. That's the number that's going to go up here. So this would be your part A answer. Sorry, kind of made a mess of that. Your sigma notation. Okay, then from there you need to evaluate it. So now we're going to put it into the sum formula. So sum equals, you would do the 40, right? This top number here, 40 over 2, 40 terms, times the first term, -5, that's over here, plus the last term, 268, and plug that into your calculator, and you get 5,260. Did you get it? Hopefully you got it. Let me know if you have any questions.